Welcome to the second lesson on building feature-rich text encodings for Python. In this lesson, we're going to take a deeper dive into using TF-IDF. So TF-IDF stands for Term Frequency Inverse Document Frequency. All you need to know about this is it's a bag of words approach. So essentially, we extract each word out of a document. We don't really care about the ordering, and we do a count of the number of times this word appears in the document. And where the inverse document frequency comes in is essentially what we want to do is we want to give a higher weighting to the word if it appears less often compared with a word that appears all the time. I suppose the logic of it is this: if the word the is used and is present in almost every document, it doesn't really give you much information in terms of how useful this word is. So therefore, it shouldn't be worth as much as a more historic word like Python in this case. So what we're hoping to see is that there is some kind of signal between words that appear less frequently versus words that appear all the time. So that's the intuition behind TF-IDF. But let's jump in and take a look at how this would work. So on the screen I have what I generated in a previous lesson. But what I'm going to do now, rather than rerunning this code all the time, is I'm going to firstly export it as a text file so that we can launch a new notebook and have a look at it there. So let's do dataset.csv. Okay, and let's open a new notebook, and I'm going to call it lesson 2. Alright, so we're going to read in this dataset, and we're also going to import a TF-IDF vectorizer which comes from scikit-learn. So let's firstly import the TF-IDF vectorizer, and it's very straightforward. IDF vectorizer. And what this does is it builds up, and allows you to do a fit transform for a bunch of text to a bunch of numbers, which is what we want. SPD. And I'm also going to use a very quick model called the stochastic gradient descent. I'm not going to go into much detail in terms of what this model is, but I will. But if you are interested, please check out my other classes, which will talk about machine learning in a bit more depth. So to start off with, let's read in our data set. So df is equal to pd.read.csv dataset.csv. All right, so we can read our data set in. So the next thing is, well, what do we do about our TF-IDF? And all we need to do is we firstly create our vectorizer object. We'll stick with the defaults because that should be sufficient for our use case today. And what we need to do is we just need to run this over all our documents. So vectorizer dot fit transform. So I'm going to call this output, and I want it for text only. Okay, so this will generate some output, and if you look at output, you will see that it's quite gibberish. It should be a sparse matrix, but it's not terribly useful. So if we look at the very first row, you just get a bunch of numbers, almost all zeros. What's more useful is if you want to see what word is associated with what column, because there's a lot of columns here, as you can see. It's 18,000 columns. What you can do is you can run vectorizer.getFeatureNames. You can see there's a lot of junk actually. So based on this, maybe you want to do something else a little bit different. Maybe you want to strip out certain words as part of your vectorizer. So how or what might we do in this particular scenario? Well, one way is you can build your own sort of preprocessor in order to transform the text before we do that. So for example, if we just want to strip out all items that start with a number, we can use some regex to do that for us. Or maybe we actually just want to remove all numbers from our text and everything with tags. So let's just write something very quick in order to demonstrate that. So import re, okay, and let's say that we want to get rid of anything that starts with a number. Okay, so if there's a word or something like that starts with any number, we just want to remove it. So let's have a stab at what this might look like. So re sub, and we want something that you have a boundary, and it starts with something between 0 to 9, and then we want 0 or more things that are like alphanumeric. So A to Z, 0 to 9, maybe a full stop, question mark. Actually, I'll leave those alone for now. And we want one or more of that, and we want a word boundary. And what we want to do is we want to replace these with spaces. Okay, now, and let's test this out. Let's test this out on a string that's like hello world and 001 and 0 ABC. And hopefully, if this runs successfully, it will strip out 001 and 0 ABC. Let's see what happens. And there we go. You can see that that strips it out. So this may be one way how we can do it. So let's encode this as a preprocessor that we want to do. And but this isn't quite sufficient, because we probably want to replace multiple spaces with just one space as well. But let's encode this in a function first. So let's call it cleanup of our text, and let's see how we might do this. Let's replace this with text, and then from here what we probably want to do is we want to probably replace multiple spaces with a single space for text, and we probably want to strip this as well, and this should work. And this should be sufficient. So let's have a look at how this would work on our dummy text. So if I add spaces, that should be removed. Hello world, 001, 0 ABC. Okay, so we should just get hello world at the end of this. And there we go, we get hello world at the end of this. All right. Okay, so what does this have to do with anything with our vectorizer? So let's try to do this by using the build preprocessor. Use preprocessor equals cleanup, and hopefully this will run, and we will get something of output that is a bit less. And if we get get feature names, you'll see that they're a bit more useful, but it's still not perfect. There's still some things that start with numbers which shouldn't have happened. I think it's because there's a underscore here, but on the whole it looks like it's working a little bit better. Now, I think that because there's a lot of words that now have mixed capitals and whatnot, it's probably better just to do a to lower, and that's just an assumption that I'm going to make, that this will improve the performance of our model, because it should really be all the same. So let's see what happens when we do this. So there we go, we have even less number of columns that we have to worry about, and now when we run our get vectorizer, you can see that there's just still some feature names. So here now I even want to let's remove some of the things that start with underscores. Actually, that may be a bad idea, because anything that starts with underscores probably refers to the Python program. So instead, what I probably want to do is remove things that start with numbers and have an underscore afterwards. So let's do that right here. And whilst I'm at it, I'm going to add, I'm just leave our underscore, and I'll also add a dash and also a dot. Simply because I think that will remove a lot of noise. Let's see what happens when I do that. Bad character range. Maybe I have to not do that. Oh, because that's not a character range. Alright, so that needs to be escaped. There we go. So now that should remove just a little bit of information. So now we have this one remaining. And I think we can start and live with that in terms of building our model. Okay, so from here, how do we build a model? So we have our transform text, but this isn't really how we want to build a pipeline. Instead, scikit-learn has a make pipeline functionality. So import make pipeline. And what this allows you to do, this allows you to simply define a pipeline and run a whole model through it. So to do that, what I'm going to do is I am going to define this to be my X, which is my input. And I'm going to define Y to be my label. And I am going to write a pipeline. So my pipeline is equal to make pipeline. And make pipeline will have this TF-IDF vectorizer, and I'm also going to use stochastic gradient descent classifier. Make pipeline is not defined because I misspelled it wrong. Okay, and then here if I run my pipeline.fit of xy, it should just run and do everything perfectly if it worked. I'm missing how to initialize it. Alright, so it looked like it fit. How do I know the performance of this? So to do this, we can just look at some metrics. So from scikit-learn .metrics import accuracy score. Now I can't always remember what accuracy score does, so let's look at some of the documentation. Do that within Jupyter Notebook, you just add a question mark and it'll tell you. So we should have y true, y pred. Okay, so that means what I want to do here is I want a y and I want to do a what my pipeline dot predict on my x. Okay, so my accuracy score is 99%, which is really, really good and probably demonstrates that there's some difference between these two things. But I'm not going to dive into that too much longer or delve into the machine learning side. If you are interested in that, please check out my other classes. So I'm going to stop the lesson for now for lesson 2. In my next lesson, I'm going to have a look at how we can just build some features